All right, so today we are ready for lesson 4.2. Just to backtrack a little bit, lesson 4.1 we were interested in compound interest and how that impacts certain savings accounts, CDs, that type of thing, interest that is in our favor, in other words. Today, the other side of interest, when we have to take out a loan for the purchase of something like a car, or later on in the lesson we'll look at when we take out a loan for a house, that's called a mortgage. So that's going to be the focus of today. You can see our title, How Much Car Can You Afford? Not just cars, but we're going to look at when we do have to take out a loan for any kind of major purchase, then we're going to look at a couple of formulas that one of them will tell us what the monthly payment will be for a particular amount of money that was borrowed. And then we'll look at a spin-off of that formula that will tell us if we know how much of a monthly payment we can afford, what does that mean we'll be borrowing in total. So those are going to be the two primary formulas that are going to be used today with your calculator. So let's get into some definitions first. We're talking about installment loans. With an installment loan, you borrow money for a fixed period of time. That's called the term of the loan. And you make regular payments. That means the same payment. And typically, these are monthly. Every month you make the same payment. And that will pay off the loan plus any interest that's been factored in, accumulated during the term of the loan. So basically, with an installment loan, when you take it out, there's three primary important pieces of information that will determine what your payment is, how much interest you'll pay. Number one, of course, it really depends on how much you're borrowing, the amount borrowed, and we call that the principal. We also need to know, the financial institution will tell us what the interest rate is, and we call that the APR. That's an annual rate. And then the term. So how long are we going to be able to, how many months is it going to take to pay off the loan? And typically that can be negotiated. Just keep in mind that the longer the term, the more interest you're going to pay. So it's in your best interest, if you take out one of these loans, to pay it off as soon as you can to try to avoid paying extra interest. So a lot of people like that lower monthly payment, but that means typically you're extending the term further into the future. So yeah, it's good to have that lower monthly payment, but if you just make the monthly payment for that long period of time, you're going to be ended up paying more interest in the long run. So that's something to keep in mind. Okay, so let's take a look at our first formula. So you definitely want to have a calculator handy. I'm just going to basically show you which formula to use, and then as you're watching this, it's really going to be up to you. You got a cheat sheet, calculator cheat sheet in class that will be really helpful. So using that cheat sheet, see if you can key in the numbers. And this really becomes an exercise in using your calculator correctly. You're not going to have to memorize these formulas. They'll be provided, but you just need to know how to use them correctly. So for my first example, we'll go through these pretty fast. If I'm borrowing $5,000, all right, so look at 5,000 goes in amount borrowed. We're multiplying by the rate. Now this rate, as you can see on your cheat sheet, it's the period rate. So it's the APR divided by 12. Okay, so that would be 0.06 over 12. 1 plus 0.06 over 12. You can see that on your other sheet. T is the, as you can see here, it's the term in months. All right, so if you're told 3 years, then t will be 36. All right, so now that we've defined all of the variables, see if you can go to your calculator, and you should come up with 152.11 as the monthly payment. So if you weren't able to get that, maybe hit pause and make sure that you can correctly enter the formula into your calculator. That's going to be huge for today's lesson. The total of all the payments will be the monthly payment times the term in months. So this was 3 years, so that's times 36. So the total of all the payments will be $5,475.96. So to find out how much interest was paid, we take this total of all payments and we subtract off the amount we borrowed, the principal. And of course that difference will be the amount of interest that was paid on this loan, $475.96. Okay, there's our first example. Here's another one just to practice the formula. So see if you can correctly enter the formula taking the information from example 2, and your result here should be 199.08. So if you need to, hit pause, practice entering the information incorrectly, and if you find you're just not able to do that, let's meet, come and see me, and we'll look at what you're doing in your calculator and we'll isolate what the issue is. But if you follow that sheet I gave you, again, if you follow that to the T exactly, pay attention to the detail, then you should end up with this amount. Well, a cousin to the monthly payment formula is the amount borrowed formula. So using some algebra, we can turn this around. You can see there's a difference here. If we know how much we're able to pay monthly based on our budget, what does that mean we're going to end up borrowing? What's that lump sum we'll be borrowing? So here we are again, an opportunity for you to use your calculator, and notice on your cheat sheet I have it called AB, amount borrowed. See if you can come up with this number for example 3. So that's 83.41.43 will be the total amount borrowed that will produce a monthly payment of $250 for 3 years. All right, so hit pause and make sure you're able, don't just assume, make sure you're able to use your calculator correctly. Another opportunity to use this formula, so see if you can, for example 4, take your amount borrowed formula and see if you can come up with this amount borrowed for this scenario. That would be $13,286.65. Okay, I'm going to go on to number 5, but again, if you need to stop and work on that, obviously hit pause. So number 5, we're going to do each. We're going to find out what the monthly payment would be in this case. $15,000 is the amount borrowed, 3.5 years, so 3.5 times 12 will be our T value, that's 42. R is again 0.09 divided by 12. You always put R in as that fraction, the APR divided by 12. So the answer for 5A should be a monthly payment of $416.67. And then to get how much interest we will have paid, we take the $416.67 and we multiply by the number of months that we'll be making that payment. And we'll get, let's see, $416.67 times 42. That's $17,500.14. We borrowed $15,000. So the interest amount on the loan would be $2,500.14. So anytime they ask for how much interest has been paid, take the monthly payment times the number of months total in the term, and then whatever that product is, you'll subtract from that the amount that you borrowed. Okay, well, letter B, we've realized we can't afford this much of a car. We are only able to make a monthly payment of $300, not the $416.67. So what price car are we looking for that will fit our monthly payment need? So here we are again using this amount borrowed formula. Your monthly payment is $300. Same R as before. T is still 42. R is still 0.09 divided by 12. And you should, if you use your calculator correctly, you'll end up with a car that's worth in the area of almost 11,000. So you really should not go over this number, stay underneath that number in order to keep your payment where you say you're able to manage them without any trouble, $300. Okay, so I'll just say this or less. That's like the ceiling. Okay, here we are again. How much interest will we have paid? So we have to know what the monthly payment is. So pull out your monthly payment formula and let's see what we get. Okay, so for letter A, hopefully you were able to come up with a monthly payment of $433.79. So determining how much interest we will have paid, we take the $433.79 monthly payment and we're going to multiply that by 12 months, 1 year, and you'll get $5205.48. $5205.48 is the total of all the payments that were made. So the interest amount of that would just be subtracting off the original principal, and that would be $205.48. All right, letter B is a review of our previous lesson where we used the compound interest formula. So we're investing, in this case, a $5,000 CD, so P, principal, is $5,000. 1 plus the interest rate as a decimal divided by the number of compounding periods. It's compounding monthly. And then 12 times 1, since it's 1 year, our exponent will be 12. All right, and when you go to your calculator, you'll get 5,388.16 if we invested. So in letter C, they want you to make a comparison. Interest paid to us at the end of the year, going back to letter B, would be $388.16. So the question really being asked in letter C is, why is there a difference here? If we're investing, we would get paid $388.16. If we're loaning, or if we borrow, we would pay out interest of $205.48. Well, the reason here is because as you pay a loan, every time you make a payment, you reduce the amount of principal, and principal is what the interest is based on. Whatever the outstanding principal, the outstanding loan amount, that's what interest is applied to, the interest rate. So that's continuing to shrink as you go through the term until you reach the end. So in one of these loans that we call an installment loan, you always pay more interest at the beginning. So first few payments you're paying mostly interest, pretty large percentage. But as you work your way through the term, you're paying less and less interest. And then those final few payments are mostly principal, very little interest. So that's just kind of an explanation. With an investment, we're actually compounding interest. We're making interest on previously earned interest, so that should continue to accumulate. So just a little comparison there between borrowing versus investing. The good interest of borrowing versus the interest you really want to try to stay away from if possible in taking out loans. Okay, let's talk about the rule of thumb 4.2. Pretty easy concept here. For all loans, the monthly payment is at least the amount we would pay each month if no interest were charged, which is the amount of the loan divided by the term of the loan. So the thing to keep in mind, a rule of thumb is an estimate. If we just want a quick number to use as a guide, then this rule of thumb is a good little tool to pull out. Here's what it says, example 7. We can afford an $800 payment. So using a quick estimate, the rule of thumb 4.2, if we're borrowing $20,000 over 24 months, this is all the rule of thumb says, well, that would produce, not even factoring in interest, that would produce a payment of $833.33. So we know just from this rule of thumb, that's going to be that's the lowest amount. It's going to be a little more than that because of interest being factored. So we know we can't afford this. The answer, can we afford to borrow? No. That's going to be the rule of thumb 4.2 makes our number higher than what we say we can afford. And then here's another one. Rule of thumb 4.2 says 18,000 divided by 36. That would be $500. We say we can only afford $450. So again, we can't afford this loan. And again, it's an estimate, but it's a good, quick little way for short-term loans. Long-term loans, I would not do this. There's another rule of thumb that we're not going to talk about, but if it's just a short-term loan, then usually that's going to be 5 years or less. This is a good little tool to pull out. All right, we're going to end our lesson with amortization tables. So let's take a look. These are used for any type of installment loan, but these are especially shown, or they're used when it comes to mortgages, which are much longer term, either 15 or 30 years are typical terms. Most of them are 30 years. But this will give us a little taste of how an amortization schedule, could be known as an amortization table, how they're made. So we have to first come up with the monthly payment. So we're using that formula again that we looked at the beginning of the lesson. So let's see if you can use this correctly and come up with a monthly payment of $88.85. All right, so what we'll do here is we'll start with a balance of 1,000. So that'll be on a row all its own, just to kind of get things started. And then they only want us to make the schedule for the first 6 months. So leaving some space, I'm going to bring down, I'm just going to create my lines for the 6 payments. The payment is the same every month, so that's the $88.85 that we came up with. So we can just fill that in. Every month the same. What will vary, though, is how much of this payment is applied to interest. And I mentioned earlier, early on, most of it's going to be, a pretty high percentage is going to be applied to interest. And then that's going to decrease as we make our way through the loan. So $1,000 is where we start, and so the amount of this payment that's applied to interest is that previous outstanding balance times, and then take your interest rate and make it, instead of an annual, make it a period rate. In other words, what is it per month? So if you do 12% divided by 12, that's 1% each month. So 1,000 times 1% is $10. So that's how much of this payment, the $88.85, goes to interest. So the amount that's applied to the balance will be the payment minus the interest amount applied. And then the outstanding balance that remains will be the 1,000 that we started with, and then subtract off the $78.85. So we're only reducing the original principal by the amount that's applied to the balance. So that doesn't include the interest amount. All right. Now when I go down to payment number 2, I'm going to use this previous outstanding balance, and I'm going to apply interest on that. So $921.15 times 1% is $921. And so the amount applied to the balance will be the payment $88.85 minus $921, and that's $79.64. So the outstanding balance will be the $921.15 minus the $79.64. That's $841.51. And you just continue on this same way. Now I'm going to apply interest toward that outstanding balance. 1%. That's $8.42. So the amount applied to the balance will be my payment minus the interest. That's $80.43. And then $841.51 minus $80.43 is how much is still left on the balance. And so you can see how it's pretty repetitive. Now I'm going to do the $761.08 times the 1% interest. That's $761. $88.85 payment minus the interest that was applied will show me how much I get to apply to the principal. And now my original previous outstanding balance minus the $81.24 gives me my new outstanding balance. All right, so once you've done one of these, it's not too bad, kind of repetitive. That's $6.80. Subtract off the payment amount, the interest applied from the payment amount, and that gives me $82.05. Notice I'm increasing as I go on. I'm increasing the amount that I get to deduct from the principal, and I'm paying less in interest. $597.79, and then one more times 1%. That's $5.98. Subtract it. 82.80. Let's see, what is that? I can't read my number. I think it's 82.87. Yep. And then 597.79 minus 82.87 is 514.92. Okay, so that is that first example, example number 9, showing how an amortization schedule works. All right, so we'll take a look at another amortization schedule problem. This is example number 10. So the first thing we have to do, like our previous example, is come up with the monthly payment. So we're going to use this formula again, so make sure you're able to key in the numbers appropriately and calculate the monthly payment correctly, and hopefully you get a monthly payment of $55.91. So we're only supposed to do, oh, this is for the first 6 months. All right, so we'll do payments 1 through 6. $55.91, and that's pretty much all the way down. This $55.91 fills up this whole column. The amount applied to interest, I should have left some space here, so let me back this up. We'll put our outstanding balance first, so it's $1,000, and then we'll start with our payments. And this is a schedule that shows with each payment how much is going to interest, how much is taking off the principal, and then what is our ending balance amount that we owe. So $55.91, and then applied to interest, we need to do the 30% divided by 12. Right? And that's going to be 2.5%. So 2.5%, or 0.025, we'll show it as a decimal. 0.025 times the previous outstanding balance, which is all of it before our first payment is made. So that's going to be $25. And the amount applied to balance, applied to the balance owed, will be the $55.91 minus this $25, and that's $30.91. And now to come up with the new outstanding balance after that first payment, we do $1,000 minus $30.91, and that's $969.09. I think I'll just do 3 payments. I think you can get the picture. So all of these are $55.91. This time we're going to be doing 2.5% times the previous month's outstanding balance. That's $969.09. And get that number. So I did not write that number down, so let's do that real quick. 969.09 times 0.025, that's $24.23. So $55.91 minus $24.23 is $31.68, and our new outstanding balance will be $969.09 minus this $31.68, and that's $937.41. And we'll just do one more, $55.91. Now we're going to apply the percentage times the outstanding balance after payment 2, so that's $937.41, so 2.5%, and let's get that actual number. 37.41 times 0.025 is 23.44. So $55.91 minus 23.44 becomes the amount applied. $55.91 minus 23.44 is 32.47. And 937.41 minus 32.47 becomes the new outstanding balance after payment 3, and that's 904.94. Okay, so we could continue on. Let's go ahead and define an important term when it comes to these amortization schedules. They let us see how much equity we have in our property, whatever that is. This could be a house, it could be a piece of land, a real estate, car, whatever. So what is equity? If you borrow money to pay for an item, your equity in that item at a given point in time is the part of the principal you have paid. So let's just take our example here. Wouldn't have a whole lot of equity yet in this particular case. I would take the $1,000 that I borrowed and I would subtract off what I still owe, $904.94. So the amount that I've actually paid is how much equity I have. So in this real simple example, the amount of equity that I've built up is how much I actually have paid off, which is $95.06. So this outstanding balance, this is technically how much I owe. So this much of it, of whatever it is that I've purchased, still belongs to the company I purchased it from. What I've paid off is the part that is actually mine. So equity is really your financial stake, how much of it actually belongs to you because you've paid that much of the loan off. That's one way you can think of equity. And it's important because it can determine a lot of things. If we sell our house, the equity is how much of it we're going to get from the sale of the house, and then the balance of the principal that's still owed, still outstanding, obviously that would go back to the finance company, but equity represents the amount that we get when we sell our house. So, and it also can determine certain things, we'll talk about this later, like a collateral on a loan. Okay, we'll just do a quick example here. Let's get the monthly payment for example number 11. Using our formula, that would be $1665.31. So make sure you can use the formula correctly. We're only going to do 4 months here, so we're borrowing $150,000. And payments 1, 2, 3, and 4, all we need to worry about. So the 1665.31 will be this whole column, just repeated. And then how much of the first payment is applied to interest? It will be 150,000 times 6% divided by 12. So 0.06 divided by 12 is 0.005. So I'll just write it out this first time. 150,000 times 0.005 will be the amount of this first payment that's applied to interest. And that's $750. So the amount that's going to be applied to the balance will be $1665.31 minus the $750 that was paid in interest, and that's $915.31. And then the new outstanding balance will be the $150,000 minus $915.31. Type that again. That is $149,084.69. Okay, so now our next interest applied from the next payment will be this number, 149,084.69 times 0.005. And that should be 745.42. So just like we did in the previous examples, the previous outstanding balance will be applied to the monthly interest rate. Then you do 1665.31 minus 745.42, and that's how much will be applied to principal, and that should continue to go up. and then our previous outstanding balance minus this balance applied, or this number applied to the balance owed. And we will have 148, 164.80. All right, now that balance gets multiplied times 0.005. That's 740.82. Our applied to balance owed figure, the payment minus 740.82 is 924.49, and the new outstanding balance is the previous outstanding balance minus 924.49. 147.240 and 31 cents. And we'll do one more. So now 147.240.31 gets multiplied by 0.005. And you can tell the amount that's going to interest is going down. The amount that's going to principal is going up, which is typical. You pay interest more in the beginning, less as you get closer to the end. So this number is 146.311 and 20 cents. So what is your equity in this land after 4 months? Well, we do 150,000. That's how much we borrowed, minus the amount that we still owe. That's the outstanding balance. And that difference represents our equity in the property. So that should be 3688.80. Okay. Home mortgages. This is a mortgage. Probably seen that term before. That's a loan for the purchase of a home. It's a specific long-term loan that's just for buying a home. Most of them, not all, but most of them are set up to be paid over a 30-year period. There are some that are set up on 15 years. So those are the two common mortgage terms, but I would say most are 30 years. The early mortgage payments, like we said earlier, go almost entirely toward interest, with a small part going to reduce principal. As a result, your home equity grows very slowly. Home equity is important. We mentioned this earlier because it tells you how much money you can keep if you sell your house, and it also can be used as collateral. If you go to the bank and you want to borrow money from the bank for a personal reason, they're probably going to ask you, well, what assurance do we have that you could pay this back if something happened? And that's what collateral is all about. Okay, so let's see, let's take this example 12, and this will be our last example. Your neighbor took out a 30-year mortgage for $300,000, 9% APR. So let's first find out what that monthly payment is. So let's go to your calculator and figure out our monthly payment, if you'll do that now. So hopefully you were able to come up with the monthly payment of $2,413 and 87 cents. All right, now let's see how much interest she paid. Well, let's find out first how much she paid in total. So we take our monthly payment, and she will have made a total of 360 payments. It's 30 years. And that's a total of $868,993.20 that she will have paid at the end of 30 years. Well, the loan originally was $300,000, so the difference is how much she paid in interest. She paid $568,993.20 just in interest. So the interest only amount that she will have paid at the end of 30 years is almost 2 times the amount of the house itself, the amount of the original mortgage. So her statement, she says that she will wind up paying more in interest than for the home, Is that true? Yeah, it's definitely true. That shows you um, when you have these mortgages that are 30 years, you can really end up paying a lot in interest charges. So if you want to combat that, if you can afford the monthly payment, it's better to go to a 15-year. The payments are higher, but the interest that you pay over the term is less. And you can do some other things too. Some people, they do a 30-year, but they pay maybe two payments if you're able to do that. You just do a double payment every month, and that helps reduce the principal amount quicker, and it lowers the amount of interest that you pay over the life of the loan. So, but if you just run it out 30 years and make the payments as they're scheduled without paying extra, you can see with this example how much you end up paying. Now that's a pretty high interest rate, 9%, but good example of why it's better to make up, if you can, save up some money, make a down payment, lower that principal, which helps save a lot of interest money in the long run. Last thing I want to mention is adjustable rate mortgages, just for future reference. Some of you aren't ready to buy a house yet, obviously, but some of you will down the road. And you'll see advertised adjustable rate mortgages. Well, let's contrast them with fixed rate mortgages. A fixed rate mortgage will give you, you'll start and end with the same rate. So you lock in at 7% a month, or APR 7%. Then it stays 7% until the 30 years is up, or the 15 years, whatever term you decide on. But with an adjustable rate mortgage, you may start off the first 3 years with a fixed rate, and then after that, it could vary. It could be adjustable. And that's dangerous because it's based on the prime rate that is in existence at that particular time in our economy. And people have really gotten in trouble. Maybe they locked in the first 3 years at a really good 3 or 4%, and then at the end of that 3 years, it's based on what the economy rate is, and that could double, and people have really gotten in trouble with these adjustable rate mortgages. So just want to throw that out there as information. Not going to really affect what we're doing in our problems, but just want you to maybe file that away for future reference when you start to look at houses. You definitely, you're kind of risking a lot here. All right, so you're always better off, even if maybe the fixed rate mortgage is a little bit higher than the first 3 years or the first 5 years of an adjustable. I still think you're better off because you never know what's going to happen with that rate after that first 3 years or the first 5 years is up on the adjustable rate mortgage. Okay, well, that's all we have for this lesson. Let me know if you have any questions.